go to it.
We would like to challenge problem number 4, unsinkable disk.
We are set.
Okay, so the report accept the challenge for problem number 4, and so the report you have 5 minutes to prepare. And in the meantime, please write down the name of your representative. Okay, so the reporter have 12 minutes to present.
Hello to all the juries and the competitors. I'm Surya Lu from Jai Senior High School, and I'm a reporter of question number 4, Unthinkable Disk. Okay, and here's the problem statement. A metal disk with a hole at its center sinks in a container filled with water. When a vertical water jet hits the center of the disk, it may float on the water surface. Explain this phenomenon and investigate the relevant parameters. Okay, and here's our observation. I observed that when the disk floats, the surface of the disk is always lower than the water level. And here's my theory. I thought that the force caused by a pressure difference affects the most. Here, PA stands for the atmospheric pressure, and PB stands for the pressure underneath the disk. So we know that PB equals PA plus rho times GH, and FA equals PA times the area, which is PA times pi r squared. And FB equals PB times area equals PB times pi r squared, which is PA plus rho GH times pi r squared. So this is the force diagram. The downward force should be same as the upward force. So we get the formula that is PA plus rho GH times pi r squared equals PA times pi r squared plus like gravity mg. And here's my experiment. We wanted to know what is the actual effect on H when we change mg. So we prepared 4 different ways of the disk. And what we need is a CD disk and 5 $10 coins. The faucet which provides the vertical water jet and 1 big straw. And here are some setups. Because we didn't have a metal disk, so we tried to use CD and stick coins today. And we measured the volume of the disk using a vernier caliper. And we found out that the disk with 2 coins weighs 29.65 grams, and its volume is about 15.43 centimeter cube, and the density of it is 1.922 grams per cube centimeter, and which is obviously bigger than water. And we watched many videos on the internet, and we can see small dents in the center of the disk. The dent ensures that the water jet doesn't splash in different directions and hit or drown the disk. So to solve the problem that the CD does not have a dent in the center, we connect one end of the straw to the faucet and inserted the other end to the water through the hole of the disk. And this is our experimental procedure. When we stick 2 coins to a CD disk, it weighs 29.65 grams. And when a CD disk floats, I measure the height difference between the water, the surface of the water and the surface of the disk, and the height difference equals 0.25 centimeters. And when we stick 3 coins to a CD, it weighs 37.29 grams, and the height difference will be 0.3 centimeters when it floats. And when we stick 4 coins to a CD, it weighs 44.76 grams, and the height difference is 0.35 centimeters. And when we stick 4 coins to a CD disk, it weighs 52.47 grams, and the height difference would be 0.45 centimeters. So here are our results. By the known value of m and the formula we just derived in a few pages before, we can calculate the theoretical value of h, and we put them in the same sheet. And we made it in a chart that the orange line would be the theoretical value, and the blue line will be the actual value. The results are close to the theoretical value, but the actual value of H seems always a little bit lower than the theoretical value, which means there is likely another upward force. It could be surface tension or a force of water flow from below. But because it's difficult to measure the angle of theta, so we didn't measure the value of surface tension. But we still discussed the effect of surface tension. And the surface tension would provide an upward force to the disk. The surface tension is measured in force per unit length. So, which means that the force would equals the surface tension times the length. And in this case, the length would be the circumference of the disk, which is 2 pi times r. So now we know that Ft, which stands for the tensile force, would equals the surface tension T times 2 pi times r. So Fty, which stands for the vertical direction of the force, should be the same as Ft times cosine of theta, which is T times 2 pi r times cosine of theta. So here's my conclusion. The upward force should be the same as the downward force. So Fty plus Fb should be same as Fa plus Mg. So we put a formula that we just derived into this formula, then we can get the final one. T times 2 pi r times cosine theta plus Pa plus log gh times pi r squared would be the same as Pa times pi r squared plus Mg. And here are some problems of my experiment and the possible improvements. The first problem is the way I measure the height difference is quite inaccurate. So I think if we can use vernier caliper to measure the height difference, maybe it will be more accurate. And the second, I think that the data of our experiment is not enough. So maybe we could try other material to experiment more different kind of ways. Thank you very much.
Okay. So the opponent can ask question to the reporter. We have 2 minutes.
Which force you think is the main force to let the CD float?
The force caused by the pressure difference.
Okay. Can the CD float without water hit on it?
Sorry.
Can the CD float without the water jet hit on it?
We observed that when we open the water, we turn on the water and it could float, and when we turn off the water, it could still float on it. So I think.
Okay, thank you. Do you consider the flow velocity on this?
Because we watched many videos on the internet, and there are some of the videos that there are no water flows on the surface of the disk. So we didn't do our experiment with float on the disk.
Okay, thank you.
We also
do you consider the boundary condition of the disk of the CD if it can float or not?
No.
Okay. Please turn to the observation video page. So there's no water on the CD, right?
Yes.
Okay. And what do you think is the function of the hole on the disk?
Is for the water jet to go through.
Also, you think that when the water jet goes through, it will cause the pressure difference?
Yes.
Okay, thank you. And can you control the velocity of the water?
We didn't.
Okay, thank you. And so, you think, so when you turn down the water, it can, why does
Okay,
it
time is
still
up.
float?
The opponent have 3 minutes. Okay. Okay, the next stage is for the discussion and for up to in 40 minutes, and the person have the first up to 4 minutes.
Hello, honorable juries and fellow competitors. I'm the opponent from Team Selfie. Today I'm going to oppose problem number 4 on sinkable disc. A metal disc with a hole at its center sink in a container filled with water. When a vertical water jet hits the center of the disc, it may float on the water surface. Explain its phenomenon and investigate the relevant parameters. And here's my main focus. Why a metal disc with a hole can be unsinkable? And how does the vertical water jet affect our sinkable situation of the disc? And the approach that we can divide the structure of solid problem into 3 parts. First, we need to identity of the force acting on the metal disc with a hole. And the opponent thinks that the most important force is the pressure difference, and also including the impulsive force, gravitational force, and the surface tension also need to be considered. And the second part, we need to investigate of how a metal disc with the hole be unsinkable while the vertical jet hits it. And we are going to discuss and put main focus on the disc with the hole, and also about the vertical water jet. And at last, we need to investigate of how the unsinkable situation change under parameters. And here are some parameters that the opponent think that's the most important part that will affect the experiment. And here are some strong and weak points of a reporter. First, she has a clear observation video of unsinkable, and here she has a clear experiment setup. But he has no quantitative explanation of the phenomenon, and she only tells us it's because the pressure difference can cause the disc to flow. And she over-idolized the theoretic model because about the pressure difference. And she has failed to prove that surface tension won't affect the experiment. And she has no explanation of the influence of the hole. And he can control the stability of the flow tube. And she has a lot of variables. She only measures the height between the disc and the water surface. And here are some points that the opponent will discuss in the further discussion. First, I want to discuss about the force that's acting on the disc. And the most important part is the pressure difference caused by the water jet, and also about the Bernoulli principle. And the second one is about we need to discuss about the force that's acting on the disc, and of course the gravitational force. And then we're going to discuss about the unsinkable situation. And I want to because we think that the approximate that disc with the hole, so I want to discuss with the reporter and what's the relationship with the hole and the stability. And next is about the vertical water jet. And I want to discuss about the motion that's when the vertical water jet hits the disc, and they have the water under the hole, and when it's spread out on the disc, and also the beneath of the disc, and the stability of the flow. And here are some parameters that the opponent discussed in the further discussion. And of course, the problem statement that you have a disc with a hole, and so will be main focus on the hole of the hole on the disc, and also the mass of the disc, and also the radius of the disc. And next, the last one is about the water jets. That's the main reason that caused the disc to flow, and also mainly about the flow logarithm rate and the flow velocity. Thank you.
Okay, let's continue.
Okay. Why do you think you said the CD can flow is because of the pressure difference? And can you please tell me why they have pressure difference above and under the disc under the CD?
There would be the water surface would be higher than the surface of the disc, so there will be a pressure difference.
Okay, so you mean that they have pressure difference because of the height difference?
Yes.
Okay, so then why do you turn down the water jets that this still can float?
I think that is because of the surface tension.
You think because of the surface tension? Okay, and at this part, the opponent disagree with the reporter because I think that, and because I think when you close down the vertical water jet, this still can flow is because of the density of the CD is smaller than the water, so the CD can flow.
But we, calculated the density of the CD and the coins, and it is.
So when you put CD and when you put coin on the CD, can the CD still can float without the vertical water jet?
No.
Okay. Do you think you will have the water or convection under this? Under the CD?
Wait a second. Oh, okay. Yes.
Okay, so you think that, or this maybe that's when the vertical water jet goes through the hole, you will turn back and have the convection to support the disc to go.
Yes, and I think this is one of the reasons that the water surface will be a little higher than the
So
surface.
you mean that if the water convection that gives the disc and support force, so the disc will be deeper than the surface? Water surface? Okay, never mind. And in your experiment, and you put coin on the CD, and so when you close down the water, the CD can flow.
Yes,
So you calculate the distance between the CD and the water surface.
but when we turn off the faucet, and it can flow, but if we disturb the water near
Okay,
it.
thank you. Upon think that the reporter should do the experiment with the metal disc because I think okay, never mind. So you mean that the only function of the water jet is to have the water convection to let the disc go. Okay. And what do you think? How will the flow velocity affect the experiment? Okay, never mind. Okay, may I use a blackboard?
Yeah, sure.
Okay, thank you. So, what do you think if we now do an experiment with a metal disc? So when we just put it on the water surface, will it sink or it will just float? It will sink. And why do you think it will sink?
Because its density is bigger.
Okay, so but now if we give a hole on the disc and we have the water flow heating on the metal disc, and do you think the disc will float or sink? It will float. And why do you think it will float?
Because of the
Or you think it's because the water flow pressed down the disc and so it caused the height difference or you have the pressure difference? But the opponent disagree with the report because I think when the water jet hits on metal disc, it will spread out and according to the Bernoulli principle, the potential energy plus the potential energy plus the kinetic energy plus the pressure will be a constant. So I think, and this metal disc will flow is because they have the flow velocity at here, so it will cause the velocity difference. And from Bernoulli principle, we can know that it's
we did thought of this before, but because the diameter of our water jet is smaller than the hole of the disc, and we also I said it before that we put a straw inside, so there will be no water flow on the disc. So I think even if there is no water on the disc.
Also, you think so? The reason that will cause the edge is just because the disc have the gravitational force, so it will have the height difference.
I didn't discuss. We didn't discuss why there will be a height difference here.
So do you think the water convection will influence a lot? do you think the water convection will influence a lot?
No. We think that.
No sense. And then why? And so that means there's no importance about the water flow.
No importance of the water flow.
But you said the water flow only causes the water convection, but you said the water convection is not really big.
I said we didn't think about why there's a.
So you only observe that they have a height difference.
It's maybe because of surface tension or water flow.
So the main reason is the surface tension and pressure difference. And so.
I think it's because of both of the convection and the surface tension to cause the height difference.
Can you show me the flow convection level that can support the things to flow the line? But when you turn down the water jets, they have no convection, and so the pressure difference maybe is because you said the mass of the disk will equals to the water convection and plus the pressure difference, right? So when you turn down the water jets, so there will be no water convection. So only if we only want to support specific flow from the pressure difference, if it's not enough. So why do you turn down the water the city?
When we turn down the water jet, this will be even.
So you mean that when you turn down the water velocity, turn down the water jets, the height will be bigger? Okay. So what if the area and what if we have many CDs and that's the mass of the CD is very heavy, so how do you think the area of the CD will affect the experiment?
Because the force equals the pressure times the area. So when the area gets bigger, the force will get bigger.
And in your the conclusion part, do you have the FA and what causes the FA?
That is the atmospheric pressure.
Okay. So you mean the air pressure?
Yeah.
And so.
I want to say that about when I turn off the water jet, it will still float. I think it's just be for reasons from the yes, that perfectly.
You mean just the downward force is equal to the upward force?
Yes, it's just because it was balanced perfectly at that time. So if we did disturb the water here.
We use the mathematics, and how do you think that we can add the mathematics to go? I mean, increase the velocity so have more water convection. When we change the DD into the metal disk, and how do you think we can add the disk?
I think the metal disk will be same as the DD disk because both of them density is bigger than water.
So
Okay, time is up, and the opponent, you have 2 minutes to summarize the discussion.
In our discussion with the reporter, I discussed the pressure difference with the reporter about the Brownian principle, but I think the main reason is the main reason is because of the height difference that caused the pressure difference, and I don't think so. And about the surface tension, she knows they have the phenomenon, but she didn't measure it in theory. And about the stability of the disk, she said that even though you turn off the water jets, the disk still can flow. So I think this experiment have there's not I think they do the wrong direction of the experiment. And about a vertical water jet, she said that the water jet is smaller than hole, so they have no spreading out on this. And through the hole, she said the main reason is the water convection, but I think I don't have no water convection. And
Okay, time is up. And next stage that you have 2 minutes.
Okay, so I have questions for both the reporter and the opponent. Please give me in short answer, like yes or no, or in one sentence. So first is for the reporter. What do you think is the main reason of the phenomenon?
The force caused by the pressure difference.
And the opponent?
You mean CD1?
Yes.
I think it's a surface tension.
Okay, and what are the key factors? Short answer, please. Key factors?
Just
Surface tension.
Yeah,
Yes.
Okay,
pressure
so
difference.
did you consider the diameter of the middle hole?
Yes, 1.5.
And how do you think the flow rate would affect the result? Is like how much water you per second?
I think that doesn't affect.
And
I think if the flow velocity is increased,
short answers, please.
it's like
Increasing the flow rate.
increasing flow rate, they have more upward flow because of the bubbles.
Okay, so did you consider the pressure of a water jet or the pressure of the water rebounding from below?
The water.
Yes or no, please?
The water.
Bouncing from below.
I think it depends. Depends on the depth of the container.
Okay, so do you think these are the important factors that would affect the result?
You mean the
All the questions I asked.
I think
Yes or no?
not really. In this, you mean in her situation?
Yes.
I think the only important
Yes
part
or
is the
no?
surface tension.
Okay. So are there any error analysis or standard deviation in your experiment?
Okay.
Any error analysis? No. Okay, so for the opponent, I would like to ask that do you think there's any error in their measuring method of the height of like edge?
Of course, you already said that.
Okay, so since that, how do you define edge in your, because there's a curve I saw. How do you define the edge? At the edge?
No,
Okay, so it's not clear enough. Do you think the edge should be considered at the edge?
You mean that the edge is only caused?
Short answers, please.
Let me finish my statement. So
Okay, so then I think you did not know what I'm clarifying, so that means
because that's not
So how do you think the buoyancy would act on the phenomenon? Buoyancy.
you just give it that lifting force that can let it see flow.
So are there any horizontal movements of the disc? Horizontal?
no.
Okay, so for my last question, as you just said that Bernoulli is important, are there any restrictions of the Bernoulli principle?
I think in her situation, the main reason caused the sea
Okay,
is
time
not the
is up.
burning.
And then reviewer, you have 2 minutes to present or to prepare.
Okay.
Okay, I'd like to start my review for the question number 4 on simple disk. So first, the problem statement, which we should main focus on the phenomenon of floating disk and the relevant parameters. So first is for the summary of the reported. We can see that the disk floats when vertical water jets hit the center. Water level around the disk is higher than the floating disk. And the theory is the pressure difference is the main cause of this phenomenon, and the experiment is just considering the weight. So for the probe, she have a clear comparison between theoretical and experimental results. And she has improvement for future experiments, the calculation and observation video to be clarified. And the cons is she has unclear definitions of the height, which the opponent didn't give me a clarification at my short question. And she has unreasonable experimental methods such as sticking points, which the mass distribution is changing and the shape is changing too. And the measurement of height, which I just said, is not considered because there's a cohesion force on the ruler she is using. And there are not enough parameters but only weight, and there are no error analysis I can see in her report. And she did not include unstableness of the water body, which is like vortex or horizontal movement. And there are two simple phenomenon explanation. So then is for the opponent. For the pros, he pointed out boundary condition which should be considered, pointed out droplet rebounding and lack of parameters. But for the cons, he has some trivial short question and lack of deep discussion in some important specific questions. And he did not clarify the importance of his question he's asking, which I cannot have an agreement on that. And he gave some vague suggestions to improve the experiment result and did not put much discussion into the experimental method. So then it's for the first discussion. And the opponent asked, why is there pressure difference? And the report just said that it's because of the height. And the reviewer agreed that the water pressure is mainly caused by the water level difference. However, also believed that the force diagram is too ideal. Like she said, their surface tension should be considered because the shape at the edge is different. And for the next discussion, the opponent disagree with the reporter and think that CD will flow because the density of CD is smaller. But the reporter said that the disk can flow without water jet due to surface tension, and she measured the value of density is bigger than water. So for the reviewer, the reporter didn't give evidence that the CD could flow without water jet, so we think that CD will sink is because the density is bigger. For the next discussion is the convection under CD. The opponent asked, are there any there will be no convection if there is no water jet and the CD will not flow? The reviewer said yes, though it's not mentioned in the report. And the reviewer agrees with the opponent because we don't think convection is not the main cause of the why CD flow. So for some points missed is like the experimental method such as measurement of height is not clarified, and why are they sticking points which changes the mass distribution. And sticking points may lead to different force diagrams because I just said mass distribution and shape, and there might be some horizontal movement which leads on to the different water height on the surface. And some of the clarification which I asked in my short question for the definition of height is on the edge or at the middle of the curve of the shape, we cannot understand. And we think that the importance of the diameter, changing the diameter of the mid-center and the flow rate of the water jet should be considered because it's important because there might be an impulse of the water jet on the disk to make it sink. And for the opponent, he mentioned about Bernoulli effect, but we think there's some restrictions like the lines on there to be considered if he can assume that. Thank you.
Reporter, you have 2 minutes to make your remark.
Okay, and here's my conclusion remark. First, I want to thank for all of your suggestions, and to the reviewer, I want to say that I measured it on the horizontal surface, like this one, instead of the edge of the curve. And second, we did try to find out the effect of water flow above, but it always turned out to the water flow to drown or tip the CD. So I think this is also a difficulty of this experiment. And third, when turning off the water jet, the disk is horizontal bed perfectly because of the convection before. So the surface tension is just enough for it to float. But the reason the disk floats when we turn on the faucet isn't surface tension. And about the reviewer, about the mass distribution, we measured the angles and the length, so but we still can't solve the problem of the shape. And next, we also think that the convention isn't the main cause of the phenomenon. Thank you.
Okay. So we have 5 minutes for questions from you. Okay,
Question for the reporter first. If the disk is hydrophilic surface, you feel it break down. Okay? If your disk is hydrophilic, your disk surface is hydrophilic, then your theory is
Yes, yes.
so the hydrophilic surface will flow.
You mean when the water you mean they have a change the when the water spread out they have the change the potential energy to kinetic energy have the
If the surface is a disk, there will be a dam. The water will go over the surface.
Oh, you mean why it won't?
So then the disk would not flow on the surface. Can you show the picture of your theory?
Okay.
The reason it will flow is the high frequency because the surface is hydrophobic. Therefore, the water will go down. But if the disk is hydrophilic, the water will go over the disk.
Oh, I know it, but I think that will cause the high Stephen is because it's only because the thing. I think I know about like the hydrophilic drop. You know, so you mean the water and the sphere and have
Will
a
the disk still flow?
yes.
Why?
You mean in her situation?
Yeah.
It's because this surface tension will let the water slip on the disk. Okay, so we think that it is like what you said, the water is over the disk. Like we mentioned about like if there's horizontal movement, there will be the same result as what you just said. So we think that it should be we should reconsider the height, which in this case, if it's still enough to overcome the mass of the disk, then it will flow.
Okay. Are there any questions?
Okay, I have a question for the reviewer. You point out two key parameters. One is flow rate. The second is the size of the hole. Could you elaborate a little more about these two?
Okay, so in my imagination, if the hole is too small and the water is too big, so there will be some water going onto the surface, and the water should press down the disk because she did not. When the opponent says that if it's flat, there's no hole on it, there will be a difference. So we think that it's considered should be like the flow. The hole is the hole size will affect this the pressure, and if the flow rate is big enough, so and the depth is not high enough, and we think that the water will goes down to the bottom of the bowl or something and rebound. So give the disk another force to lift. So we think that the flow rate should also be considered, like the rebounding. And if the flow rate increases, the pressure will increase, like in my imagination.
Okay,
You can answer that question.
Opponent wants to say something.
I think if the you mean if the hole of the disk is too small, the cross section area of the water flow is bigger than the hole, then so just like the reviewer said, they will have
water spread out on the end. I think the disc still can flow is because when the water spread out, they have a flow velocity, and under the disc is more like there's no water flow. So because of Boiling principle, when the flow velocity is bigger, the pressure is smaller. So they have a pressure difference that causes the disc to float. And if the hole is too big and the water will go through the hole, I think if the disc will sink, it's because I think if the depth of the container is big enough, then they'll have no water convection, so the disc goes.
Okay, so probably reporters say a few words. 5 seconds.
Water jet, the diameter of our water jet is smaller than the hole in the middle of
time is up.
the disc.
Okay, thank you. Thank you.
We have some time for the jury to share your work. Okay, so if everybody okay ready, then we show the scope. So the numbers this way, yeah, 6, 6, 5, 5, 6, and then we show the score for the opponent. So the scores are 7, 7, 6, 6, 7. And then finally we show the score for the reviewer. Professor Gao, could you turn this way? Yeah. 7, 8, 6, 7, 8. Okay. So we have another 10 minutes for break.